Properties of addition. Properties of addition. Here we go. One of the properties of addition is a thing called the commutative property. Now, when you hear the word commutative, you kind of think of commute, right? Like when someone commutes to work, they go, they travel. So this idea of commuting kind of gives you the sense of motion, movement, travel, commute, right? Okay. The commutative property of addition tells us. The commutative property of addition. You ready? Okay. This is a real difficult one, so stay with me. 3 plus 4. Okay? 3 plus 4, we know that that's 7, right? The commutative property says that we can make these guys travel, take him and put him there, take him and put him there, and change it to 4 plus 3, and still get 7. Commutative property of addition. You can flip-flop the numbers and it does not change the value. The identity property. The identity property, this is the sensitive property. The one that doesn't want to lose its identity, for goodness sakes. Suppose you got a number such as this one, -6. And -6, oh, please, don't let me lose my identity, but we must do the math. Well, I know, but don't let me lose my identity. There's only one way that we can do that. And for addition, that is to add a 0. So the identity property keeps the number the same as the answer. In other words, it will not lose its identity. Now, you'll notice down here this word element. An element is like a thing or a part of something, right? So, remember this, because you will see it. The identity element for addition is 0. That's the element, that's the thing for addition that will allow this poor, insecure number, whatever it is, in this case -6, to keep its identity. The identity element for addition is 0. Got it? The associative property. This one's a fun one. Sometimes an illustration is better than an explanation, and you'll see why in a second. I'm going to write -3 plus 2 plus 7. And then I'm going to write -3 plus 2 plus 7. Okay? Here's what the associative property says. The associative property says that I can group these two associates together, or I could group these two associates together, and the answer will not change. It does not affect the outcome. What? How can this be, you ask? This just shows how smart you really are, asking an intelligent question like that. Let's work this out, and you'll see that the answer will remain the same. Now, if you remember your order of operations, it's grouping symbols, exponents, multiplication and division, addition and subtraction, or PEMDAS if you like. I like Gemma. Okay, we have grouping symbols. In this case, it's these guys upstairs, and downstairs, it's these guys, okay? So let's take care of our grouping symbols first. -3 plus 2. If you remember your rules for signs for addition and subtraction, the rule says that if the signs are opposite, which they are, if the signs are opposite, you subtract, so 3 minus 2 is 1, and the answer takes the sign of the larger number. In this case, 3 is larger than 2, and 3's sign happens to be negative, so the answer is -1. Now let's go downstairs. We've got a +2, well actually this is positive because there's no sign in front of the 2 directly. We've got a +2 and a +7. Our rules in that case say if the signs are the same, which they are, you add the numbers, 7 and 2 is 9, and the answer takes the sign of the problem. Well, since they're both positive numbers, 9 is going to remain positive. Okay? So far so good? Now, let's go back upstairs. We have a -1 and a +7. The signs are opposite, so we subtract the numbers, which is 6. Answer takes the sign of the larger number. 7 is larger than 1, so it stays positive, and our answer in this case is 6. Downstairs, we've got this -3 and this 9. The signs are opposite, so we subtract. 9 minus 3 is 6. The answer takes the sign of the larger number. 9 is larger than 3, so it remains positive, and looky there. 6 equals 6. Closure property. Closure property says if you got two real numbers, two integers, then the operation will produce another integer, case closed. Closure property, right? Maybe it'll make more sense with an example. Suppose you got -4 and you got +6. This is an integer, it's a real number. This is an integer and it's a real number, right? When you do the math, you're going to end up with a 2, which is also an integer and a real number. And that closes this math. Okay, additive inverses. Additive inverses. Let's pick the number 7. Number 7 and number 7, okay? When you invert something, you sort of turn it upside down, or you do the opposite, right? So additive inverses would be the same number, 7 and 7, but with their signs being opposites, positive and negative. That's what they mean by inverse, the opposite. So the opposite of +7 is -7. Identical number, opposite signs. Okay, here's something you want to remember because you're going to come across this. Additive inverses will always result in a 0. And if you think about it, what is 7 minus 7? 0, right? 19 and 19. Positive and negative. This makes them additive inverses. They're opposites. You do the math, you're going to end up with a 0. 1,397,042. 1,397,042. Additive inverses, positive, negative. You do the math, you're going to end up with a 0. Additive inverses always end up in a 0. Identical numbers, opposite signs, additive inverses. There you go. More to come. But for now, this will conclude this video.